Good morning, friends. In my last video of alkynes, I explained you the structure formula of the alkynes. Today, I will discuss you preparations of the alkynes. First is action of water on the calcium carbide. This is the laboratory process, and also ethyne is formed on the large scale by this method. Here, calcium carbide simply reacts with water to form ethyne and the calcium hydroxide. Now, calcium carbide is formed from the calcium carbonate. Calcium carbonate, when strongly heated, form the calcium oxide and the carbon dioxide. And this lime, that is calcium oxide, react with carbon at a very high temperature, that is 2275 K. It forms calcium carbide and the carbon monoxide. So this calcium carbide reacts with water to form the ethyne and the calcium hydroxide. Now this ethyne, that is acetylene, it is explosive in nature when come in contact with the air or the oxygen. So this reaction is carried out in an inert medium or in oil gas medium, as ethyne is explosive in air or the oxygen. And second thing is that certain impurities are formed during the reaction in the form of H2S, that is hydrosulfide, PH3, that is phosphine. These are to be removed. So hydrosulfide and the phosphine gas are the impurities found during the reaction, which were removed by passing through the copper sulfate solution. This H2S, when passed copper sulfate, it forms the copper sulfide, that is a black precipitate. In the same way, phosphine reacts with copper sulfate to form the cupric phosphide, that is a black precipitate. So these are the impurities which were removed by passing through the copper sulfate, and you get the pure acetylene gas. So this is the laboratory process and the on large scale process, very simple process. Now second is by dehydrohalonation. Dehydrohalonation, that is dihalides. Here we take, that is dibromoethane, that is a vicinal halide. Vicinal halide means when halogen atom, they are joined with the adjacent carbon atoms. So this dihalide reacts with alcoholic QH to form the ethyne, KBr and the water. Actually, this reaction takes place in two steps. In one step, that is first step, when dibromoethane reacts with alcoholic QH, it forms the vinyl bromide, that is one bromo is removed. Then this vinyl bromide reacts with sodamide in the presence of the liquid ammonia, and it forms the ethyne and the sodium bromide. So this is by dehydrohalonation when heated with alcoholic QH. Now third is simple action of the zinc on tetrahalogen derivatives of the alkanes. Here if we take the example of the tetrabromoethane, it when heated with zinc in methanol, it forms ethyne and the zinc bromide. It is a simple preparation, action of zinc on tetrahaloderivatives of the alkanes, and then is by dehalogenation of the haloforms. Haloforms are the chloroforms and the iodoforms. By dehalogenation of the haloforms, that is chloroform or the iodoform, they simply, when heated with silver, they form the thiones and the silver chloride. In the same way, when iodoform heated with silver, it forms methane and the silver iodide. Now the important one is electrolysis of the aqueous solution of potassium salt of fumaric acid. That is the Kolbe reaction. That is electrolysis of the potassium salt of the fumaric acid. Now this fumaric acid is CHCOK, double bond CHCOK. Now when it undergo electrolysis process, this potassium salt form the anions and the cations, that is CHCO double bond and the potassium ion. On the other hand, water dissociate to form the OH and the hydrogen ions. Now at anode and at the cathode. At anode, this fumarate ion gives out the electron, form the ethyne and the carbon dioxide, and at cathode, this hydrogen proton takes the electron to form the hydrogen gas. So this is the Kolbe reactions. It's a very important reaction. Now the next is, that is from carbon and the hydrogen. You see, when hydrogen gas is sparked through the electric spark of the carbon electrodes, from carbon and hydrogen, so hydrogen gas is passed in an electrical carbon electrodes at a very high temperature, that is 3270 K, it converts into the ethane. So when hydrogen gas is passed through electric spark of the carbon electrodes at about 3270 K, it forms the ethanes. So this is all preparations of the alkynes. I think it is clear to you. If you like my videos, please share and subscribe. Thanks very much.